Yeah, I'm Kartika Ramasamy. I'm from Group 12, and our group members are Jamal Map, Umayma Khan, and Sabab Ishraq. And today we are going to present about open bias detection in text-to-image generative models. This paper have 23 citations so far, and this is released on August 5th, 2024. And our course advisor is Dr. Mubarak Shah. Let's see the contents that we are covering today. So these are the contents that we're going to cover today, and let's see about that one by one. So let's see about the problem. So the problem is in this paper mainly focusing on detecting bias in text-to-image generative models, and some existing methods only detect predefined biases like gender, male, female, and age, child, young adult, or elderly, and race. It's among the 7 categories. I try to figure it out. But this problem is important because the real world applications are being increasingly used to this generative models. So this is need to be figured out, like it's only predicting the predefined biases, right? It's still we need to go beyond that. So let's see, the paper produces the open set biases, like it just discover and quantify the novel biases. It's not rely on the predefined bias sets. This problem is important because in AI, all the biases are being detecting very quickly, and we need to know more like the hidden biases as well. And let's see about the hidden existing research. So the existing research is nothing but what has been done on the previous problem, and they have been performed some approaches. So which are like training related methods to mitigate biases, and data augmentation to balance the representation, and classifier based methods to analyze the generated images. So among this, what is the open bias is different from here, like how the open biases differs. So this does not rely on the predefined bias sets, and it automates the discovery using LLM to generate the potential biases dynamically. And also it uses the vision question answering model, like instead of the existing predefined generative models, to analyze the generated images from the models. And also it detects both social biases and non-traditional biases like age, gender, and laptop brand, activity, and etc. And you see, these are the identified bias type from the open bias. You see this prompt, a train zip down the railway on a sun, in the sun. So this prompt have generated some synthetic images, but it identified the train color as a bias type. As the same, you can see the toddler on a baseball cap on a wooden bench. So this identify the child and gender bias. And the next one, a photo of a person on a laptop in a coffee shop. So this identified the laptop brand as bias. So let's see the data format and the usage. So the data format and usage, this study uses the multiple data sets like Coco, Flickr, which is a large set of data set here, which contains the images and captions to it. And it uses FFHQ, and also the synthetic images are generated from stable diffusion models like 1.5, 2, and XL models. And the usage of the data set is the captions from the data sets are used as a prompt for generating the synthetic images here. And also the LLM, here they uses the llama to process the captions to propose the potential biases, and the VQA models to analyze the generated images to quantify the detected biases here. And finally, the human evaluations are used to compare open bias results with the human perception. So let's see the open bias pipeline one by one. The bias proposal, image generation, bias assessment, and bias quantification and ranking. And you see, this is the full workflow of the bias pipeline. Let's see about this one by one, how it is trying to identify the biases. So first is bias proposal. So these texts you can see here, these texts are taken from the data set, which I mentioned before. And for example, let us take the caption of here, like a photo of a person on a laptop in a coffee shop. So, and also, yeah, they are attaching another question, like what kind of bias could be show up in the image generated from this caption. So this is giving to Llama, LLM, to propose the biases here. So you can see in this equation, we can understand like what is the responses given from the LLM. You can see here T and Q. The T is a text, Q is a question, which is giving three type of outputs for us. The LLM will be giving, which is X, C, Q. So X is a potential bias, C is a set of classes, Q is question to identify the bias. So just assume the LLM have responded the biases like this: laptop brand, the classes or Apple, Dell, HP, and the question is what is the brand of the laptop, which is to identify the bias, which is given by the LLM. And taking this returned value from the JSON, they are performing two type of filters. The two type of filter will see one by one. So for that, they are taking an same caption and the question taken given from the LLM. So that filter is LLM filter. It will ask another question called, does the caption already contains the answer to the question? So in this case, it will say no. So this pair will be continuing to adding into the data set. It's nothing but this is the step how they are curating the data set. And there's another example. Suppose if the caption is like a photo of a person using a map book in a coffee shop with the same question, this time it will say S, so it will remove this pair from the data set. It does not want that one, explicitly saying that. So the another filter is filter name is concept net filter. It's taking the same question and caption on the question as an example. In this case, it will ask another question called, does this caption contain any class name or synonyms? So here it does not contain anything like that. So it will say no, it will continue the pair. So same another example, in this case, it will say S and this will remove the pair. So in likewise, it will process all the captions, whatever is taken from the data set, and it finally have the curated data set to process the synthetic images. And if you see in this workflow, after the bias proposal, the curated data sets are stored here and the captions and questions separately. And this T and Q, the text and question from the data set has been sent to the target generative model to generate the synthetic images. So let's see that. Okay, so this is an equation to identify it. Like this stable diffusion model will generate the multiple random images using the multiple seeds because the stable diffusion start from the noise. So here you can see the example of the prompt, a photo of a person on a laptop in a coffee shop have generated some 10 synthetic images. Like initially they are generating 10 images. So with that images, they are going to analyze how the biases will be. And yep. So the next one is VQA. Like after processing the synthetic images, they are processing the vision question answering process. Let's see that. So this is bias assessment. So the bias assessment has been done with the blip2 and Flanty double XL, which is using as a natural language decoder here. So you can see in this image, like they are taking the generated image and the question. That question is like, what is the brand of the laptop? So as same question they are taking, and that will be returning the Flanty double XL answer, like Apple, Dell, HP. So these values, so this is the output, and these are the outputs is going to be stored here. So after processing the VQA model, it will be processing the bias quantification, taking all the outputs from the LLM, VQA, and everything. Let's see that how it process. So it has been done in two distinct ways. So first one is a context-aware bias. So this context-aware bias, they are performing the probabilities in the each caption. So that each caption, like if you see here, so if you see this equation, so if the VQA is answered same to the classes, it will store the value as 1, otherwise it will give the 0. As the same way, for example, in this, the VQA answers for this 10 images have given like this, like 7 times Apple, 2 times Dell, and 1 time HP. So this is the class probability. This is how it performed the, compute the class probabilities. And second scenario is context-free bias. So if you see the context-free bias is nothing like they are trying to collect all the captions related to the one bias. For example, in this case, we are saying the laptop brand. So it will take all the captions overall the data set, and it will perform the average across the multiple captions here. And finally, it will perform the ranking. So that ranking has been done with performing the entropy. Like they are after this, after taking the class probability, and they are taking, they are trying to normalize the method, and they are performing the entropy classes, and finally they are making the ranking scenario. So if the entropy is low and high, based on that, this ranking will be performed, and this is how they are identifying the bias and measuring the bias. Now I'm giving over to Jamal to continue.
Okay, so now we're going to go over the pipeline's implementation. Okay, so the goal is to see how biases such as stereotypes or prejudice show up in both images and in captions. The research focuses specifically on images where there's only one person in them. They did this because people-related biases are especially problematic. They use Flickr and Coco for the multimodal datasets to see if the AI is biased when generating images and captions. And then they use those generated images to test to determine how biases those captions and images can be. Coco is a large data set, so the researchers filtered it to focus only on images where there was one single person in them, resulting in 123,000 captions. The study compares the biases in different versions of Stable Diffusion, versions 1.5, which is shown in orange, version 2, which is shown in green, and version XL, which is shown in blue. And we can see that XL generates the highest average bias intensity out of the three for both data sets. However, both three perform pretty similar in bias intensity. These data sets represent how computers see and describe people and objects. But unintentionally, the study did find that biases also extend to objects, animals, and actions. So there's biases related to, for example, animal breeds or the brand of objects. After that, they picked 100 random captions for each bias type and generated 10 images for each caption using random seeds. This gave them 1,000 images in total to analyze. The researchers experimented with different language models for the VQA, and those include the clip L, OFA large, Unplug large, blip large, Lava 1.57b, and Lava 1.513b. These models were tested on both Flickr and Coco. The accuracy and F1 scores are measured on tasks related to age, gender, and race. The higher the score, the better the model is at recognizing and reducing bias. It was found that Lava 1.513b emerged as the best performing model, so the researchers chose it as their default. After running the VQA models on both the generated and the real images, the study compared how those models' predictions align with Fairface. Fairface is a classifier that has been trained to recognize social attributes such as age, gender, and race. So Fairface was used as the ground truth for evaluating the bias in the models. KL divergence is used to measure how similar the predictions are to Fairface's predictions. So a low KL divergence means that the models are similar in their predictions against Fairface. This is another indicator that Lava 1.513b VQA model is robust and it works well on both the generated and the real images. The researchers wanted to see how well open bias system aligns with human judgment, so they conducted a human evaluation where people assess the biases in images generated by the AI models. The study used crowdsourcing, so anyone from around the world could participate. So there was no restriction on location. Each participant saw 10 different images generated from a description. These images were selected to test for different biases. So participants were asked to rate the direction and the intensity of each bias on a scale of 0 to 10. They were also given the option of no bias if no bias was observed. The bias focused on The study focused on 15 biases. As we can see, these are the 15, which include people-related and object-related biases. And a total of 390 images were used in total. We can see that open bias, shown in green, can detect bias at the same level and even better than a human would, humans being highlighted in blue. Okay. So the researchers compared context-aware versus context-free. We can see that context-free, which is shown in green, does not perform nearly as well as context-aware, which is shown in blue. This shows that context matters. The researchers observed that biases were stronger or different when models considered the full context. So, for example, if we look at motorcycle type, the bias was much stronger when the context was included. So, with the context included, the model generated motorcycles of one specific type. But in bed type, the bias remains strong on both context aware and context free evaluations, meaning that the model always generated the same type of bed, regardless of if the context was included or not. So, this suggests that some biases are more sensitive to the context, while others remain consistent across the board. Here are some example of the surveys. So the human participant would look at the description, toddler in a baseball cap on a wooden bench, look at the generated images and determine if a bias is present, what type of bias is it, and then to give a score from 0 to 10 of how biased it is. So they can say, yes, there is a bias with the child's gender. The child is always a boy. They can say, yes, there is a bias with the child's race, or they can say, no, there was no bias with the person's attire. There are some limitations that we should be aware of. Open bias is built on two foundation models, which are llama and lava. So these models have biases that are intrinsic. So those biases may propagate into the open bias pipeline. So even though open bias works well based off of the research, it does not take into account the biases that may stem from llama and lava. But it's okay because open bias is modular, meaning that the pipeline can be updated or modified. So if better models become available in the future, models with fewer biases or improved accuracy, they can be incorporated into the open bias without any major changes to the system. And then the study shows that context matters. However, the researchers did make a note that their evaluation of context is considered qualitative, meaning that it's based off of an observation and not based off a quantitative analysis. So for future improvement of the pipeline, a more systematic approach for measuring context is needed. Open bias can improve existing systems and help biases in new ways. But open bias may not be able to detect all biases, but it does raise important questions about how we detect them. We are Group 12, and thank you for listening. At this time, we are open for questions.